A spring of spring constant 5 into 10 raised to 3 Newton per meter is stretched initially by 5 centimeter from the unstretched position, right? That means basically K is equals to 5 into 10 raised to power of 3 Newton per meter, and initially delta X or the extension was 5 centimeter, which I can write it as 5 into 10 raised to power minus 2 meter, right? Now then the work required to stretch it further by 5 centimeter is. So that means initially there was some potential energy. Potential energy initial was how much? It is always half K x square, where x is the extension. That means half into 5 into 10 raised to power of 3 into 5 into 10 raised to power of minus 2 whole square, right? So this will be equal to what? 125 by 2 into 10 raised to power of minus 1, right? This is the initial potential energy. Now, what is the final potential energy? Total extension will be what? 5, and 5 was initially, so total extension will be 10. So that means half kx square. This will be equal to what? Half into 5 into 10 raised to the power of 3 into 10 into 10 raised to the power of minus 2. This is the total extension whole square, right? So this will come out to be 500 by 2 into 10 raised to the power of minus 1, right? So this is the final potential energy. Now that means there is a change in potential energy, which is PE final minus initial potential energy. Where did this energy come from? This energy came from the work done by the external agent, right? Work done by the external agent. That means this will be equal to how much? 500 minus 125, and I can take 10 raised to the power minus 1 by 2 as common. So this will be 375 into 10 raised to the power minus 1 by 2. So which will be 37.5 by 2, right? Which will be approximately 18.75 Newton meter inverse, right? Newton meter, right? So this will be the answer, right? So that means option B is correct. You know what the problem in this question was? The question is generally what we do is we always write the work done by external agent will be equal to delta PE, and we directly write it as half K delta X square, right? And we see that delta X equal to 5, right? This is the mistake that I'm telling you, that there will be a mistake. This is the mistake that most of the students will make, right? Almost all students make generally. So they will generally write it as delta X, and what they will calculate, half into 5 into 10 raised to power of 3 into 5 into 10 raised to power minus 2 whole square. Why 5? Because they have taken 5 centimeters stretched. They did not check the initial position. That is the problem. If initially there was no extension, initially it was at its natural length. If initially it was at natural length, then only this would have been correct, right? Otherwise, if there is no natural length, initially it is also stretched. Like in this case, if it is initially stretched, then you cannot use directly this formula. You have to do by this method. You have to calculate the initial potential energy. You have to calculate the final potential energy. Then you have to subtract them, right? You have to remember this concept. Do not do by this method, half K delta X square. Most of the students do it by this method and they will get their answers wrong. They will get their answer as 125 into 10 raised to the power minus 1 by 2, which will be approximately 12.5 divided by 2, which will be 6.25. So that means most of the students will mark the correct option as D, but actually the correct option is B, right? You have to remember this concept.